this lesson we'll look at the graphs of data. We're going to specifically look at categorical variables and the data they produce, and how graphs can assist us not only in seeing what the data presents, but also understanding the data. So we're going to look at bar graphs and pie charts, and then talk about how sometimes you can have misleading data according to a visual representation of the data. So the purpose of our graphs is assistance in interpreting the data. What the data helps us to do is you want to ask the question when you see the data is, what do you see? What impressions does it give? What understanding does it lead to? Now we'll start with bar graphs. Bar graphs show each category as a bar. Now bars are what we would say is a rectangle, a vertical rectangle, but each of the bars have to have equal width to them, and then the height represents how much data you have in that category. So the height shows the frequency. Or relative frequency of the categories. So you take each category, represent them as a vertical rectangle bar. Now here are the graphing instructions for this, and this is critical because again, graphs can sometimes be misleading. We don't want to mislead the reader according to what graph we draw. So you have to make sure you draw and label the axes. Make sure you scale the axis. So start usually at 0 and then use equal units. Be cautious about this. Be clear about what each thing is labeling. If you don't use equal units, again, it can be misleading for the graph. Draw the bars with category names. Their width should be equal and their height should correspond to the frequency or relative frequency. We leave the bar graphs, you leave gaps between the bars to show distinction between the different categories. So next we'll talk about what's called a side-by-side bar graph. This is to show sometimes more detail of data inside of each category. So it displays 2 or more groups for one categorical value. I'll put for each category. So you take the category and maybe break it up into specific information inside that category. All right, so let's go ahead and take this now, and we're going to look at an example here. And the example here, this is made up data, so this is meant to help us illustrate the type of graph, not actually be survey data. But this is time spent on homework for freshmen, sophomores, juniors, and seniors. How many spend less than 30 minutes, 30 to 60 minutes, or 60 to 90 minutes? We want to represent this with a graph. Now, because this has 3 different possibilities for each category here, I'm going to draw a key for how I'm going to represent that. So for instance, if I just have a bar that doesn't have any filling in it, this will be for the less than 30 minutes. Now if I take the bar instead and I put cross-hatching in it, that's a little bit further in. We're going to do 30 to 60 minutes for that one. Now if we're doing this on a computer, oftentimes they'll use different colors. For this, since we're drawing it, we're going to represent with different information. And if I fill it in like this, okay, that's for 60 to 90 minutes. So that will be how I represent. Now let's take this chart and we're going to put it onto this graph, I'm going to first of all start by labeling the graph clearly. I'm going to start at 0, and the highest percentage I have is 60%, so this is going to be 10%, 20%, 30%, 40%, 50%, and 60%. At least let us know what your units are, so we know that. And this is a percentage of students in this category for each of the categories listed by our key. Now down here, I'm going to do freshmen first. Then I'm going to do sophomores. Then I'm going to do juniors. And then I'll do seniors. Now, to do these, I'm going to go ahead and write these different bars for this data. So for the freshmen, I'm going to start with 20% for less than 30 minutes. So I'm going to go up to 20%, draw a bar, and I'm going to leave that one open because that's what my key tells me. Now I'm going to go with 50%, so I'm going to have it right next to it because we're in the same category, just with more specific data. This is for 50% spent between 30 and 60 minutes, so that's how I'd represent that. And then the next one, 30%, right next to it here. This is the one I fill in for percentage of students who are freshmen who spend 60 to 90 minutes on homework. This is the same with sophomores, 10% for the first one. Now I leave a gap for the next category. So we go up to 10% here. 30 to 60 minutes is 60%, so we can go all the way up to 60% for this one. And this one has the cross-hatching in it. And then for the 60 to 90 minutes, I'm gonna have 30% again here. So 30% matches what happens with the freshmen, and I fill this one in. And then for the juniors, start off with 30% for this one. So 30% takes me up to here. Then for the next one is 40%, so I'm gonna go slightly up for this one. And this will be where the cross-hatching occurs. And then the last one for my juniors is 30%, so back down to 30. And this one's the one that we fill in. So this data so far is telling a little bit of a story through the graph. We can hopefully understand the data a little bit more. And then seniors, 40% for the less than 30 minutes. So we go over here to 40%, draw my empty bar graph there for less than 30. Then I've got 30% for the next one, for the cross-hatching. And then lastly, I got 30% for the 60 to 90 minutes. And this one I fill in. So this data, it tells us each of the categories. It gives us more specific information for each of them as part of it. This could have been represented a different way. We could have had the amount be how much, what time do the freshmen as a total spend out of their homework time? How much do they spend on math or something like that? But this specifically was broken down into categories of how much time each student spent in that time in those grade levels. All right, let's go ahead now and move our attention to pie graphs. So pie charts, these represent the data in circles. Sometimes they're called circle graphs. This again allows us to represent the data. So it shows each category is a slice of the pie instead of a bar. All right, so the area of each slice represents the frequency or relative frequency of it. So the area of each slice is proportional to the category frequency. Now, some instructions for this, because these are circles. We have to go back to using some things we know about circles. First of all, find the relative frequency in terms of a percentage. So when you do the frequency, make sure you convert it into a relative frequency. Then use the percentage by multiplying that percentage by 360 to get what angle you're going to use. Okay, and for that angle, then you label the slices. Now, you might want to use a protractor for this, or you might want to, oftentimes when we do a pie chart, we will use the computer to guide what these, so they can get a more precise graph for it. So each of these, again, this is made up data of sock color. So what color socks are that people have. So we have white at 25%, black at 40%, none wearing socks. They're not wearing any socks, 25%, and other colors of socks or designs would be 10%. And you multiply each of these by 360 degrees, and you get your degrees for this. So this would be 90 degrees. Black, 40% of 360 gives me 144 degrees. None, to another 25%, so 0.25 times 360 gives me 90 degrees again. And then other, 10% of that would be 36 degrees. Now I'm gonna label this. Now I notice that two of them are 90 degrees. And so I'm gonna use that advantage that that's just half of a circle if I put them together. So if I draw straight across and then draw straight up, this would be 90 degrees here. That would be 25%. So I'd say white here, let's label it. This is gonna be socks, okay? So white would be 25%, I'll put in this category. Then I'm gonna put the none here in the other 25%. Okay, so 25% here. Now these, I have to measure. Now you could use a protractor if you want to get a more accurate graph. 30 degrees is right about here, so 36 degrees is a little bit bigger than that. So this would be my 10% here for other. So I'll put other here is 10%. And then lastly, this last 144 degrees left over, which is just an estimated value here. For black socks, that's going to be 40% on my graph. So make sure you label it clearly. Again, if you use this on a computer, sometimes they will color code these so that it gives some distinction between the different categories. So it's a pie chart. Now here's some information about how we can mislead the reader of the graph with however we represent the graph. Sometimes this is done with what are called pictographs. Now pictographs are where you use, you can do it accurately, but sometimes they'll just use a picture of what we're representing. So this sock data we just did, if we represent it with a sock, what they'll want to do is make it look proportional by just expanding it out. Now notice that this data here, this is 25% here for this one, for white socks. For black socks, remember, it was 40%. For none, it was another 25%. And for other, it was 10%. Now, notice how misleading this can be, because yes, this 10%, if you do 4 of them, you will get the height of this 40%. So height-wise, it's fairly accurate about representing it. But because it now involves width or area being enlarged, since the width is enlarged, I could actually fit many of these little socks in here, as many as maybe 7 or 8, maybe 9 of these socks into this bigger one, because the area has expanded. The width of it has expanded as I enlarge the figure. So be careful, pictographs, because height, when we use bar graphs, or the height represents it, the bottom width is always the same, or with our pie charts, it's always a percentage of 360, so it is accurately representing it. Because these pictographs will oftentimes have width involved as well, it multiplies the magnitude of what this graph looks like, and it can then lead to an incorrect judgment of how big this percentage is. So be careful when you see those pictographs because they can be misleading. So what we've looked at is we've looked at how to do categorical data. We oftentimes will represent those with a bar chart or bar graph. Bar graphs are where you put categories with rectangles, same width, with some distance between them to show the height as how far the relative frequency or the frequency is. We've done pie charts with that, where you use the percentage of a full circle to represent a slice of pie for the frequency or relative frequency. And then we also talked about how we could be misled by a graph that might try to represent it kind of artistically or something by doing a graph using a picture of the element. But if it also breaks that idea of equal widths on the bottom, it can mislead us on the graph. So be careful of those and try to be as accurate as you can in representing your data to the viewer.